Hello again. Our next lesson in the grand scheme of things, or math, is applying order of operations. Now when we're applying the order of operations, we have to follow a specific guideline, and here it is. Do parentheses first, then exponents, then multiplication and division, whichever one comes first from left to right. Then addition and subtraction, whichever one comes first from left to right. But you take care of your parentheses first, then you take care of your exponents, then you take care of your multiplication and division at the same time, but you go from left to right. Addition, subtraction, same time, left to right. And the saying that people oftentimes use is, please excuse my dear aunt, not aunt, Aunt Sally. Let me say that again. Please excuse my dear Aunt Sally. Sally, pardon me. And I've got this little problem here where I want to evaluate it. I've got 27 divided by 3 squared times 2 subtracted by 3. If you go from left to right in this problem, you're going to get it wrong. It's as simple as that. You have to make sure that you take care of things in the proper order. Now here's the first question. Do I have any parentheses on this example? And the answer is, no, I don't. So I don't got to worry about parentheses. But I do got to worry about exponents, because that's the next step. No. 3 squared, or 3 times 3. 3 squared is not 6, it's 3 times 3. 27 divided by 3 squared is 9. Then I can write times 2 subtracted by 3. So I took care of my parentheses and my exponents. Now I got to take care of my multiplication and my division. But when I do my multiplication and my division, I take care of it from left to right. So what do you see first? 27 divided by 9, that's first. Now somebody's going to say, well, multiplication comes before division. No, they come at the same time, but it goes from left to right. So if division goes first, then you do division first. If multiplication goes first, then you do multiplication. But you do these at the same time from left to right. Addition and subtraction, same time from left to right. 27 divided by 9 is 3 times 2, subtract 3. I'm still not done with the multiplication division step because I still have multiplication. 3 times 2, 6, subtracted by 3. Alright, I'm done with all multiplication and division for this problem. Now I just got addition and subtraction. The answer is 3, because 6 subtracted by 3 is 3. If you decided to do this in your own little way, you would get it wrong. Because you'd say, oh, 27 divided by 3 is 9, 9 squared is 81, 81 times 2 is 162, 162 subtracted by 3 is 159. That's clearly not true, because I didn't use the order of operations, and I have to use the order of operations. You know, parentheses, that's the big dog, followed by exponents, then multiplication and division, then addition and subtraction are kind of, you know, left in the whim, as it were. So we did an example of applying order of operations. I want to continue along and do a couple more examples, actually I believe 3 more examples, just to make sure that we're set when it comes to basic order of operations. With that said, let me throw out my extra whiteboard. Yay! Let's try this one. So I have to take care of parentheses first. Well, I take care of inner parentheses before I take care of outer parentheses. I've got 2 sets. I've got these, which are my inner, and these, which are my outer. I've got to take care of everything from the inside out. Like problems, you take care of them from the inside out. So I've got 8 plus 13, which is 21. Excellent. And I took care of these parentheses, so now I can just drop them like a bad habit. I got 30, subtract 21, still those parentheses, and 2. Drop down the 2, drop down the parenthesis, drop down the 30. I'm already done with these parentheses, so I'm finished. Drop down the negative, drop down that. Take care of this parenthesis, 30 subtracted by 21 is 9. I don't need them anymore, it's 2 times 9. 18. Done. I like this example because I have students who are in more advanced algebra classes that still actually do this problem wrong. Because when books write these problems, they don't actually publish the parentheses where they need to belong. It's just an assumption that you know what to do. There are actually two sets of parentheses here that you don't see. When you take care of a fraction, you have an imaginary set of parentheses in the numerator, and you have an imaginary set of parentheses in the denominator. You've got to take care of everything in the numerator separately and everything in the denominator separately. So let's take care of this. 8 plus 4 in this set of parentheses is 12. 5 minus 2 in this set of parentheses is 3, which is 4. Let's combine everything that we know. That's evaluating with variables and using order of operations to see if you can do this next problem. And hopefully, with that said, everything will be great. I am not going to put the "Please excuse my dear Aunt Sally" on top. You'll just have to memorize that yourself. I want you to evaluate this, what is it called? Expression when C equals 4. And of course I use C because that's the first letter in my last name, and I like the letter C. Now there's an imaginary set of parentheses that actually belong here, and an imaginary set of parentheses that belongs there. That actually is a little annoying to put another set, but you get the point. You got to take care of the numerator by itself, and you got to take care of the denominator by itself. And in this case, you got to take care of the inner parentheses before you take care of the outer parentheses. So let's take care of the numerator. This is 9 times 4, because my C is 4. And I have 3 times 4 plus 2. That doesn't look very student-friendly. 9 times 4 is 36. Over. I do the inner set of parentheses first. 4 plus 2 is 6. It's 3 times that. And I can get rid of the inner set of parentheses because I already took care of it. So it's 3 times whatever this was. So I have 36 over 3 times 6, which is 18. And 36 divided by 18 is 2. We're done. Have a good day for now.